Hello, math friends. Today we're going to solve linear systems using substitution. Sometimes I like to be a little bit fun and goofy, but this is such a lot of work to solve systems using substitution. There are lots and lots of steps, so please bear with me. We are just going to hunker down and we are going to work hard and get through a couple of these problems. Okay, so here we go. If we want to solve the system using substitution, we are going to take the value for one of our y's, which is right here, negative 4x minus 12, that's what y equals, and we're going to fill it in, substitute it for the y in the other equation. So it's going to give me negative 4x minus 12 equals negative 7x plus 3. Okay, now what I have to do is I have to move all of the numbers that don't have any variables on them to one side and the variables to the other so that I can get to a one-step equation. I like to move subtraction things because I get to move them using addition. So I'm going to add 12 to both sides. It wouldn't really matter, but that's just my choice. So that's going to give me negative 4x equals negative 7x plus 15. Next, I'm going to go ahead and add 7x to both sides. These cancel and I get negative 4x plus 7x will give me 3x. And then if I divide by 3 on both sides, I have now found that in this system, x should be equal to 15 divided by 3, which is 5. There's my first step. Now my next step is to fill in and see what y should equal. So if in this equation x is 5, then y equals negative 7 times 5 plus 3. Negative 7 times 5 gives me negative 35 plus 3 would give me a negative 32. So my solution to my system, I think, should be 5, negative 32. But I'm going to just double check by filling my 5 in to my second equation as well. So I'm going to go ahead and say y equals negative 4 times 5 minus 12. I go ahead and multiply, which is going to give me negative 20 minus 12. I can stop, chop, chop, and I get y equals negative 32. Sure enough, telling me that the solution 5, negative 32 is a match. I'm getting 32 out for both y's, and I solved for 5 in my original substitution. So my solution to my equation is 5, negative 32. Look at all that beautiful math work. It's so much good hard work, and you do have to do all of it in order to get to the answer and know that you're absolutely correct. So let's try one more. This one looks a little bit different because not both of them say y equals. So that just tells me that, hey, it's going to be way easier since this is already set up as y equals this quantity to fill that quantity in for y in my other equation. So I'm going to get 8x plus what y equals negative 5 plus 3x equals negative 16. This one, my first step is going to be to combine my like terms, my 8x and my 3x, which is going to give me 11x plus negative 5 equals negative 16. Now I'm going to move my whole numbers all over to one side by using my inverse operation of adding 5. Pretty good stuff. And I end up with 11x equals negative 16 plus 5 is negative 11. Then I'm going to go ahead and divide by 11 on both sides. And I think that x should equal negative 1. So now, in order to check to make sure, or to find out what my y is, I'm going to have to fill this x equals negative 1 into both equations. So let's start over here. I'm going to do 8 times negative 1 plus y equals negative 16. I go ahead, I'm going to solve for y. 8 times negative 1 gives me a negative 8. Plus y equals negative 16. And then I add 8 to both sides to get the y alone. This gives me 0, and y equals negative 8. And so now I do the same over here. I'm going to fill in for my x. and I go ahead and fill my -1 in for my x. I do my multiplication, -5 plus -3. And then -5 plus -3 is -8. So once again, I get y equals -8. So my solution to this equation would be -1, -8. It looks pretty. This is some mathematic genius. Again, I just have to compliment, wow, all that good hard work. The music's even playing in the hall because they're so impressed with how awesome we are fantastic mathematicians.